Hello everyone. This video is about critical points and extrema on an interval. So our goal is going to be able to find these critical points and extrema when given an interval and a function. So the first picture we have here is a graph with three horizontal tangent lines. So we have this horizontal tangent line, this one, and this one. And if you'll notice, all three of those tangent lines, well, of course, the horizontal, I've said that already, but they are also have a slope of 0. And that is how we find critical points. Whenever we have a horizontal tangent, we tend to have a maximum or a minimum value there. These here on this picture are local mins and local maxes. It means that right here, this point is a minimum in this local area here. This is a maximum locally. This is a minimum locally. Actually, this one right here is an absolute minimum also because it is the lowest point on the entire graph. Because this graph continues on forever, this is not an absolute maximum. It's just a local maximum. This next picture over here, it shows us an undefined derivative. Remember, our derivatives are undefined when we come to a sharp point because there are an infinite number of tangent lines there. So this is just a picture of a graph who has a critical point at this x value c, and it is found by finding when the derivative is undefined. So critical points tell us when we have a potential maximum or minimum value. All right, so we are going to look at this first example. So bear with me as I try and write through all of this. But we're going to find the critical points of f of x equals 2x to the third minus 15x squared plus 24x plus 7. I have the picture of the graph over on the right. So if you look at that for a little bit, it looks like we're going to have a local maximum at 1, and I don't know, that looks like a local min at about 5. I don't know, we'll see, but you can see where these two are at, right here and right here. So let's go through and find the derivative of my function. So, oops. So the derivative of f is going to be given by 6x squared minus 30x plus 24. And remember, we have to find where this derivative equals 0 or where it's undefined. Well, since there's no denominator on this thing, it is never going to be undefined. So we just have to worry about when it equals 0. So to do that, I'm going to factor out a 6. And from there, I will factor that quadratic in there. And that's going to be x minus 4, x minus 1. And just a quick review of algebra 2. This is 0 when x minus 4 is 0, and when x minus 1 is 0. So our critical points are at x equals 4 and x equal 1. And as you can tell from the graph here, that is right at 1 there, and this one happens apparently at 4. Okay, so now we're going to do the exact same example, only this time we are going to switch it up a little bit. We're going to put this on an interval. So we're only going to look at this cubic function starting when x is 0 and stopping when x is 6. And that's the picture you see on the right. Well, if you look at the picture on the right, it's obvious what the absolute maximum and the absolute minimum is. But we're going to do that algebraically because we don't always have a picture handy. So what we're going to do is start off where we were, start where we left off. We know f prime at x equals 0 when x equals 1 and when x equals 4. Well, when we're on an interval, we automatically have 2 more critical points. And those critical points are the endpoints. When we chop off a function, the endpoints could become our absolute max or absolute min. Well, once we have this, all of our critical points listed, we kind of make a little chart here. And all we're going to do now is plug these values into our function. If I plug 1 into f of x, I will get 18. If I plug 4 in, I get -8, I believe. If I plug in 0, I get 7. And if I plug in 6, I get 43. And now we can look at those and say, well, it's clear now that this is the absolute min. And at 6, we have our absolute max. And that is all Extrema on an interval is about. Finding the critical points, because those are our possible maxes and mins, looking at the endpoints, plugging them all back into the original equation to see which one truly is the largest and the smallest.